We have this question that reads that chlorine is made up of two isotopes, chlorine 35, which has a mass of 34.969 atomic mass units, and chlorine 37, which has a mass of 36.9666 atomic mass units. And given chlorine's atomic weight as 35.453 atomic mass units, what is the percentage abundance of each isotope? So yeah, let's look at that. Let's get into it. Atomic weight is just another way of saying the relative atomic mass. You see it, right? So in order for us to calculate the percentage abundance of both of these, we're going to consider just some normal understanding of percentages. So if I say that the mass of if I have chlorine 35, and then let's say that I say that it's 30% abundant, right? So if chlorine 35 is 30% abundant, it means that the remainder is going to be the abundance of chlorine 37. So that's just 100 minus 30, which is going to give me 70%. So that's how the abundances are related. It's just that this one is the difference of 100 by the percentage abundance of that one. So in this case, since we don't have the percentage abundance of either, we're just going to consider one to be an unknown, then we subtract it from the full value of the other. So now let me just show you what I mean really quickly. So let's say that the atomic mass is equal to the summation of all the masses given multiplied by their respective abundances, and then you divide everything by 100. That's the formula that we use. Now the atomic mass, or the atomic weight, has been given as 35.453, and it's equal to the mass multiplied by the respective abundance. So let's get the mass of chlorine 35, which is 34.969. We multiply it by its abundance. So let's just consider it to be x. You can say y, it can be any variable. So we're multiplying those and it gives us that. Then that's going to be added to, that's the reason why the sigma symbol is there. It's the summation of their respective products. So that's going to be added to, I'm just going to write that down here. That's going to be added to 36.966, which is the mass of chlorine 37, and then this is going to be multiplied by the abundance of chlorine 37. But the abundance of chlorine 37 is 100 minus the abundance of chlorine 35. You see it, right? Then this is going to be all over 100. So this is going to be 100 multiplied by that. We're multiplying by the corresponding, and we have 3,545.3 is equal to 34.969x plus, that's going to be 36.966 times 100, which is going to give us 3,696.6, and that's going to be minus 36.966 times x, which is giving 36.966x. So we're just going to group the like terms at this point. So this is how we're going to group them. So this value right here will cross the equal sign, and we're going to get 3,545.3 45.3 minus 3696.6 is equal to 34.969 minus 36.966. Let's not forget these have x's. So now I'm just going to erase this top part, and now let's continue and finish up our calculation. So what's going to happen here is that we're going to subtract these two values, and that's going to give us negative 151.3 is equal to, then we're going to subtract these two values, which is giving us negative 1.997x. We divide both sides by the negative 1.997. Yeah, same here. Negative 1.997. That's giving us x is equal to something close to 37.764%. So that's the percentage abundance for the thing that we initially placed the x on. And if you check the calculations, that was on chlorine 35. So therefore, chlorine 35 has a percentage abundance of 75.764%. But as for chlorine 37, remember it was 100 minus x, so this is our value for x. So that's going to be 100 minus 75.764, and that eventually is giving us it's given 24. So for chlorine 37, the abundance is 24.236%. So that's how you calculate the relative abundance of each.